Hello, this is Peter from Educomondo and a warm welcome to our STEAM project number 10 called the Desk Lamp. This is the teacher edition in which we pay more attention to technical and pedagogical explanations. We also give classroom management tips in order to make your STEAM lessons fun and exciting. I want to remind you that this is for the absolute beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. In this lesson, we are going to introduce a new and versatile component to our class, the push button. Push buttons are used to switch on LEDs, control motors, send pulses to the microcontroller, and so on. Most of the push buttons that are included in the STEAM starter kits are these very small devices. Luckily, there are also larger versions that are easier to handle. Let us look at the physical appearance. This push button has 4 legs. You can see that the legs are curved in a specific way. The legs that are curved towards each other are connected. The legs that are more parallel towards each other are not connected. On the whiteboard, you can draw these legs and show what is happening when the button is pushed. When pushed, a connection is made between that pair of parallel legs. This is important to remember because you can easily install a button the wrong way. The purpose of today's project is to build a simple project to make an LED light up when pushing the button and go off when releasing the button. We also will learn about the what and the why of pull-up and pull-down resistors. We will practice with our class the if-else command, and of course they will be working as a team to program and build the project. Sometimes you may hope that for your students it will not work, because they will have to be critical about what they have built and have to think logically to find their error. And that's the moment when they really start to learn. Let's distribute the components to your students. The microcontroller and the breadboard. This time we are going to use a cheap clone just to show you that you can have the choice. 1 push button, 1 LED, a resistor of 220 ohm, a resistor of 10,000 ohm, 4 jumper cables, a red and a black one to be aligned with the standard color coding for positive and negative, and 2 white ones, 2 preformed wires, a short and a somewhat longer one, and let us not forget the most important part, the desk lamp. Before your class can start building the project, we need to explain the what and why of pull-up and pull-down resistors. Let's say you have a microcontroller with 1 digital pin configured as an input. The microcontroller continuously listens to the state of that pin. Is it high or is it low? This phenomena of uncertainty is referred to as floating. To prevent these random changes between high and low, a pull-up or pull-down resistor ensures that the pin is in either a high or a low state, and not in this in-between state of uncertainty caused by external electromagnetic noise in the air. Let's draw a pull-up resistor first. This is the push button, and I draw the 4 legs to get as close as possible to the real component. The left pin is connected to 5 volt from the microcontroller via a 10,000 ohm resistor. The other leg is connected to the ground. Because the button is not pressed, there is no contact between the upper and lower leg. We will listen to the state of the button by adding a connection from the top right pin, connected to the 5 volts, because these legs are connected with each other. Because the current can flow to the read pin, it will read a 1 and the LED will be off. When pushing the button, the circuit is closed and the current will go to the ground. The reading from the pin will turn into 0 and the lamp will go on. It is very similar with a pull-down resistor. We attach the 10,000 ohm to the lower left leg going to the ground, when the button is not pushed, there is no current and the digital pin will read a 0 while the LED is off. When closing the circuit by pushing the button, the current flows from the positive to the ground, and the read pin will pick this up as a 1, and the LED will switch on. Show your students this drawing. It will help them to put the components in the right places. You can leave this image on your computer in front of the class or project it on a wall or whiteboard. Give your students 10 minutes to build the project on their own. Let's start building. The legs of the push button need to be placed correctly. They are quite small and your students need to remember where the curly legs are. Some of the small push buttons don't fit firmly on the breadboard as the legs are really tiny and short. We are using a bigger button to make this easier to show. We connect the pull-up resistor of 10,000 ohm to the left lower leg of the button and connect this to the 5 volt supply of the microcontroller using the red jumper cable. The right lower leg is connected to the ground rail. The upper left leg is where we will read the state of the push button, and we connect this one to one of the digital pins. For this project, we use pin number 3. Now we can connect the ground rail to the ground pin on the Arduino. Next, we build the LED circuit. Connect the positive leg of the LED to the 220 ohm resistor, and the negative leg to the negative rail on top of the breadboard. Because the LED will be getting its power from a digital pin, we connect the positive leg to pin number 9. The last thing we need to do is to connect the two ground rails so that the LED's short negative leg is also connected to the ground. Ask your students to connect the microcontroller to their computers and let them open the Arduino Integrated Development Environment. At the top, they should create a new sketch called Lesson 10 Desk Lamp. This is also the right place to declare your variables. We have two digital pins that we want to give a name. The pin that listens to the state of the push button will be the button pin. So INT button pin equals 3. We will call the pin connecting to the LED the LED pin. INT LED pin equals 9 and ending with a semicolon. Because we will need to capture the state of the push button, either pressed or not, we also declare a variable called button value. And it never hurts to declare a delay. This time we go for 1 second. INT DT equals 1000. In the setup section, we initialize our digital pins by using the pin mode command. Pin mode and in between brackets LED pin, comma output. And then we also will activate the button pin, and this time it is going to be an input. This is an input pin because we will be reading from it, namely whether the status of the push button is pressed or not. We also want to check our project on the serial monitor. We need to start this also with a command. Serial.begin and in between brackets the baud rate 9600. That's it for the setup section. In the loop section, we first have to tell the microcontroller what the variable button value is. Button value is what we will read from the digital pin called button pin. So button value equals a digital read and in between brackets from the button pin. We know that that value is going to be either a 0 or a 1. And here we can use the if-else command. If, between brackets, button value double equal sign 1, close the brackets and open the curly brackets. And note that we are using a double equal sign. We check whether the value is equal to 1. We do not set the value to 1. Make sure that your students understand the difference very well. So in the curly brackets, we include the action that will happen if the button value is equal to 1. And that action is a digital write to the LED pin, and we put it to low. So to recapitulate, if the push button is not pressed, the input pin will read a 1 and the LED pin will be set to low. On the other hand, the moment we push the button, the input pin will read a 0 and the LED pin will be set to high. Else, in between the curly brackets, digital write, and in between brackets, we put the LED pin to high. Because we also want to see the input pin value on the monitor, we add the following print commands. Serial.println, and the value that we want to see on the serial monitor is the button value. And to slow this down, so we can actually monitor what is happening while pushing the button, we add the delay of 1 second. When we don't push the button, the values are 1s. When we push the button, the value turns into 0 and the LED goes on. I think your class is now ready to upload the program and push that button. Their desk lamps should now be going on and off while they are pushing and releasing the button. If it doesn't work with some of the groups, tell them not to panic. Tracking and correcting errors is one of the most important skills in programming. Encourage them to do some logical fault finding by asking the following questions. What was the error message on the microcontroller? Did you end all commands with a semicolon? Did you spell all commands correctly? Did you put the wires in the right pins? Did you declare the right pin numbers as a variable? Are all connections on the breadboard firm? Or maybe some of the components are broken. Before we conclude this project, we just want to show that you can also use a push-down resistor setup. The result is the same. This concludes our project number 10, the desk lamp. What did we learn? We used a new component, the push button. We have learned about pull-up and pull-down resistors and why we need them. We practiced the if-else command. And the most important, we have been working as a team to program and build a project and doing some logical fault finding. I hope that you and your class enjoyed this lesson, and I'm eager to start with our 10th project. In that lesson, we will work with a ball switch. The ball switch is a digital switch that controls the on or off of a circuit while being tilted to one or another side. We will use this switch to build a digital hourglass. Bye bye for now.